Hi students, today we are going to discuss about our new chapter, Soil, Chapter 9. We know that soil is one of the important natural resources, right? It supports the growth of plants by holding the roots firmly and supplying water and nutrients. We know that it is the home for many organisms. Soil is essential for agriculture also. Okay. Soil is thus an inseparable part of our life. Okay, so we can move to the important points we want to discuss in this video. A soil profile, soil types, properties of soil. These are the three important points we want to discuss in this video. First of all, we are moving to our first topic, soil profile. What do you mean by soil profile? We know that soil is composed of distinct layers, right? When we take a little soil and break the clumps with your hand to powder it, then now take a glass tumbler, 3/4 filled with water, and then add a handful of soil to it. Stir it well with a stick to dissolve the soil. Now let it stand undisturbed for some time. Afterwards, observe it and note the difference. So we can see that it converts into different layers. Do you see layers of particles of different sizes in the glass tumbler? Yes. So the rotting matters or rotting dead matters in the soil is called what? Humus. Okay, it is seen above the layer. The first layer, humus. What is it? The rotting dead matter in the soil. And you know that the soil is formed by the breaking down of rocks by the action of wind, water and climate. Okay, so this process is called weathering. What do you mean by weathering? The soil is formation of soil by the breaking down of rocks particles by the action of wind, water and climate is known as what? Weathering. This process is known as weathering. The process of formation of soil. Okay, so we say that soil is composed of distinct layers. So the vertical section through different layers of the soil is called the soil profile. Okay, we know that the nature of any soil depends upon the rocks from which it has been formed and the type of vegetation that grows in it. A vertical section through different layers of the soil is called what? Soil profile. Okay. Each layer differs in texture, color, depth and chemical composition. These layers are referred to as horizon. Okay, we say it as horizons. These layers are referred to as horizons. There are different layers. Okay. So, yes, we usually see the top surface of the soil, not the layers below it. If we look at the sides of a recently dug ditch, we can see the inner layers of the soil. Right? Such a view enables us to observe the soil profile at that place. Soil profile can also be seen while digging a well or laying the foundation of a building. It can also be seen at the sides of the road, on a hill or at a steep river bank. Then this is a picture of different horizons. The uppermost horizon is called a horizon. This is the surface horizon. The zero is O is the organic. This is not termed as the horizon. This A is the first horizon. A is the upper layer. A horizon, B horizon, C horizon and bedrock. These are the 4 layers or 4 horizons of the soil. Okay, now we can discuss it in detail. First one, A horizon. Yes, it is the surface horizon. Okay, the uppermost horizon is generally dark in color as rich in humus and minerals. We know that this uppermost layer is consists of rich in humus. What do you mean by humus? Yes, dead particles, rotting particles. Yes, about this humus and minerals. The humus makes the soil fertile and provides nutrients to growing plants. This layer is generally soft, porous and can retain more water. It is called this topsoil or the hay horizon. So we can say that this uppermost layer is a horizon and it is very rich in humus and minerals, and also this humus makes the soil fertile and also it provides nutrients to growing plants. This layer is very soft and porous. What will be porous? It contains holes and can retain more water. It can retain more water, and this layer is called topsoil or a horizon. Okay, this is the surface layer. Second one is B horizon. This provides, we know that this A horizon to provide shelter for many living organisms such as worms, rodents, moles and beetles. Okay, the roots of small plants are embedded entirely in the topsoil, this A horizon. Okay, the next layer has a lesser amount of humus but more of minerals. Okay, this layer is generally harder and more compact, and this layer is called what? B horizon or middle layer. And the third layer is called C horizon, and which is made up of small lumps of rocks with cracks and crevices. It is made up of small lumps of rocks with cracks and crevices. This is the third layer, C horizon. Below this C horizon, there is a layer called what? Bedrock, which is very hard and difficult to dig with a spade. It is the innermost layer. So these are the different horizons of soil. Okay, next we are going to discuss about the soil types. What are the types of soils? Soil types. As you know, weathering of rocks produces small particles of various materials. This includes sand and clay. The relative amount of sand and clay depends upon the rock from which the particles were formed. That is the parent rock. So, the sand and clay depends upon the parent rock. We know that what I mean by a soil, the mixture of rock particles and humus is called the soil. The soil is classified on the basis of the proportion of particles of various sizes. Okay, living organisms such as bacteria, plant roots and earthworms are also important parts of any soil. The soil is classified on the basis of the proportions of particles of various sizes. So, based on this, they are classified into three types. Soil is classified into three types: sandy soil, clay soil and loamy soil. First one, sandy soil. So, from this word sandy, sand, right? The soil contains greater proportions of big particles. We know that sand is a big particle. Sand particles are big particles. So, the soil contains greater proportions of big particles. Sand particles are quite large. Okay, and they cannot fit closely together. So, there are large spaces between them. You know that sand particles are like that. They are big particles and also they are not fit closely together. So, there is a gap between them, large spaces between them. And these spaces are filled with what? Yes, with air. The sand is well aerated. So, we can say that sand particles or sandy soil is well aerated. And water can drain quickly through the spaces between the sand particles, right? Because there are so many spaces, so water can drain quickly through these spaces between the sand particles. So, sandy soils tend to be light, well aerated and rather dry. Okay, so it is very simple topic, sandy soil. Sandy soil it contains greater proportions of big particles, and these sand particles are quite large. Okay students, now we can move to the second type of soil. What is that? Clay soil. If the proportion of fine particles is relatively higher, okay, then it is called clay soil. If the proportion of fine particles, not big particles, fine particles is relatively higher, then it is called clay soil. Clay. Okay, clay particles being much smaller packed tightly together, leaving little space for air. Yes, you are very familiar with clay soil, right? You know that we can make so many things like toys with the clay particles. Why? Because these clay particles are much smaller and also they pack tightly together. So we can make things by using clay soil, leaving little space for air. Then unlike sandy soil, water can be held in the tiny gaps between the particles of clay. Okay, so clay soils have little air, but they are heavy as they hold more water than the sandy soil. It can hold more water than the sandy soil, but sandy soil can hold lesser amount of water compared to clay soil. Okay, next one, third one, loamy soil. Okay, what is loamy soil? If the amount of large and the fine particles is about the same, then the soil is called what? Loamy soil. Okay, there are same amount of large and fine particles. Okay, if the amount of large and fine particles is about the same, then the soil is called loamy soil. The best topsoil for growing plants is what? Yes, loamy soil. The best topsoil for growing plants is loamy soil. This loamy soil is a mixture of sand, clay and another type of soil particle known as slate. So it is a mixture of sand, clay and slate. Slate occurs as a deposit in river beds. This is a soil. Slate is a soil which is occurs as a deposit in river beds. The size of the slate particles is in between those of sand and clay. The loamy soil also has humus in it. Okay, it has a right water holding capacity for the growth of plants. So we can say that this loamy soil is best topsoil for growing plants because it contains same amount of large and fine particles, and also it is a mixture of sand, clay and slate. Slate, what do you mean by slate? Yes, this occurs as a deposit in river beds. This is another type of soil particle. And the size of the slate particles is in between those of sand and clay. And also loamy soil contains what? Humus. Okay, and also it has a right water holding capacity for the growth of plants. Okay students, these are all about soil types. There are three types of soils which are the sandy soil, clay soil and loamy soil. Okay. So next we are going to discuss about the properties of soil. You have listed some uses of soils. Let us perform some activities to find the characteristics of the soil. So we can go to one activity.
When water is added to soil, the water we add has to pass through in-between gaps or channels in the soil particles. The speed at which water flows through the column of soil is known as percolation rate, and percolation of water depends on the particle size of the given soil sample. Let us see. For this we need 3 funnels having a cotton plug at the end, conical flasks, 20 grams each of sand, loamy soil, clay, and 3 beakers with 50 milliliters of colored water. Put the sand in the first funnel, loamy soil in the second, and clay in the third. Now pour the colored water slowly over each type of soil. Observe the amount of water percolated. After some time, pour out the water which seeps through the funnel. You see sand has the highest percolation rate, while clay did not percolate any water. So clay has the highest retention capacity. If we observe the particle sizes of these samples, we see that the particle size of sand is biggest, followed by that of loam, and clay has the smallest size. So percolation rate through a column of soil is directly proportional to the size of the particles. A soil is a mixture of particles of different sizes. Collect 3 different samples of soil from 3 different places and compare percolation rate of water through them.
Okay students, percolation rate of water in a soil. So what do you mean by percolation rate of water? Is the rate of water movement through a soil. Okay, the rate of water movement through soil is called percolation rate of water in a soil. So its equation is given below. Percolation rate, this in its unit is milliliter per minute, is equal to amount of water divided by percolation time in minute. Okay. Okay students, now we can move to the second property, moisture in soil. Take a boiling tube. Put 2 teaspoons or spoonfuls of a soil sample in it. Then heat it on a flame and observe it. Let us find out what happens upon heating. So we can say that on heating, water in the soil evaporates, moves up and condenses on the cooler inner walls of the upper part of the boiling tube. Okay. On a hot summer day, the vapor coming out of the soil reflects the sunlight and the air above the soil seems to shimmer. So we can say that there is a moisture in soil. Okay. Next property is the absorption of water by soil. We can move to one video.
Experiment. Absorption of water by soil. Take a beaker, funnel, filter paper, few samples of soil, and a dropper. First take a filter paper, fold it and place it in a funnel. Place the funnel in a beaker. Fill the funnel with 50 grams of soil. With the help of a measuring cylinder, measure 100 milliliters of water. Pour the water on the soil with the help of a dropper. Pour the water in such a way that it spreads over the entire surface of soil. Keep pouring the water until the water just starts dripping from the funnel. Now measure the quantity of water left in the flask. Let us assume that it is 60 milliliters. So we conclude that water absorbed by 50 grams of soil is equal to 100 milliliters minus 60 milliliters, which gives us 40 milliliters. Considering the fact that 1 milliliter of water weighs 1 gram, the water absorbed as a percentage of the weight of the soil is equal to 40 grams divided by 50 grams multiplied by 100, which gives us 80%. The experiment is repeated for different soil samples. So we can conclude which soil absorbs the maximum water, which absorbs the least. Generally, we conclude that the rate of absorption of water is higher in clay soil than sandy soil.
So we can say that soil have absorption capacity. Okay, so these are the properties of soil. First one, percolation rate. Second one, moisture of soil. And third one, absorption of soil. Okay, the last section is soil and crops, the last topic in this chapter. We know that different types of soils are found in different parts of India. In some parts there is clay soil, in some parts there is loamy soil, while in some other parts there is sandy soil. Soil is affected by wind, rainfall, temperature, light and humidity. These are some important climatic factors which affect the soil profile and bring changes in the soil structure. The climatic factors as well as the components of soil determine the various types of vegetation and crops that might grow in any region. Clay and loamy soil are both suitable for growing cereals like wheat and gram. So clay and loamy soils are good for growing cereals like wheat and gram. Okay, such soils are good for retaining water. Okay, for paddy, soils rich in clay and organic matter and having a good capacity to retain water are ideal. For lentils or masoor and other pulses, loamy soils which drain water easily are required. Okay, for cotton, sandy loam and loam, sandy loam or loam which drain water easily and can hold plenty of air are more suitable. Okay, then crops like such as wheat are grown in a fine clay soils because they are rich in humus and are very fertile. Okay, so we can say that in different crops, different soils are required. Okay, these are all about our chapter. Now we can move to our last section, exercise. First question, explain different layers of soil. Second one, which are the types of soils? Third one, what do you mean by percolation rate? Fourth one, explain how soil is formed. Thank you, students.